Hello dear students, welcome back to physics online class. So in previous session we discussed about force between the static charges. So in case of that force between the static charges, for that examination point of view, so Coulomb's law is important for that 2 marks, and as well as that force between the multiple charge is important for the 3 marks, and limitations of Coulomb's law is also important for the 2 marks, and usually numerical they may ask for that 5 marks. Now let me begins with electric field. So in electrostatics I said it discussed that force between the static charges as well as field between the static charges. So already I come to know that how that force between the static charges will exert. Now we will consider that how that field between the static charge will get exerted. So in order to understand that, so electric field between the static charges, so first I will understand what you mean by that electric field here. Let me begins with electric field here. So what is that electric field here? So in generally, so for example, electric field is nothing but it is the region around a point charge within which influence can be experiencing. For example, so this is one point charge. So around this point charge it influences certain area here. For example, if this is positive charge means its influenced area is up to this much, for example. So this influenced area I am going to be name it as a electric field here. What is that electric field here? It is the region around a point charge within which influence can be experienced. So what is that electric field here? It is the region around a point charge within which influence can be experiencing. For example, I will take one perfume bottle here. So that perfume bottle having certain kind of influenced area, so that smell is influencing certain area. In the similar manner, if I take the charge, that charge particle having certain kind of influenced region, that influenced region I am going to be name it as a electric field. In case of that electric field, so I will consider uniform electric field, and non-uniform electric field here. Uniform electric field as well as non-uniform electric field. What is that uniform electric field? So uniform electric field means strength is same at different point. For example, I will take that two plate here. One is plate A and another one is plate B here. So between these two plates, wherever if you measure that electric field value, you may get that same value here. So uniform electric field means strength is same at different point. For example, field between the two parallel plate is example for uniform electric field. So what is that non-uniform electric field strength here? Non-uniform electric field means strength is different at different point. For example, if I take that positive charge here, it influences certain area I said. For example, it influencing certain area means, for example, if I take the point here, so field value goes on decreases or field value goes on changes here. So such kind of electric field I will name it as a non-uniform electric field. So hope you understand here. Electric field in the sense it is the region which influences a electric field, or so in case of that electric field we can call that so what that electric field here? So electric field is nothing but it is the region around the point charge within which influence can be experienced I said. So in case of that understanding electric field, first I will understand some basic points here. So for example, source charge. So source charge also we can call it as a point charge as well as a test charge here. What is that source charge and what is that test charge here? So source charge is a charge which can produce the electric field. What is that source charge here? Remember one thing, source charge is nothing but it is a charge which produce the electric field, the charge particle which can produce the electric field. So that charge I will name it as a source charge here, and another one is test charge here. So what is that test charge here? So a charge which can test the effect of source charge. For example, I am having one source charge here. I want to get that information about that what is the effect of this source charge. In order to get the effect of this source charge, I want that another one charge here. For example, this is one source charge. I want to get the effect of this source charge, in the sense at what region or up to what region it is influencing here. So for example, at a region from that source charge, I will take one point here. So here that source charge I consider here. I want to understand what is the effect of this source charge. In order to understand the effect of this source charge, I need another charge. That another charge is nothing but a test charge here. For example, here test charge in the sense a charge which can test the effect, or a charge which can test the effect of source charge. For example, how the source charge is going to be affected, I can calculate on the basis of the test charge here. What is the test charge then? A charge which can test the effect of source charge. How the source charge is going to be affect, I can understand by the test charge. Suppose here also if you place the source charge, then what happens here? One charge is exerting force on the other. This other charge is exerting force on the first charge. So I may not get that effect of the charge here. So in order to understand the effect of source charge, I will consider that test charge here. So test charge in the sense a charge which can test the effect of source charge. Its magnitude is very much small. So hope you understand here. So in case of electric field, so I will understand that what is that electric field strength. So electric field strength. So hope you understand these small points. So remember those definition. So next one is electric field strength here. So electric field strength. So this electric field strength also I will name it as the electric field intensity. Electric field intensity. Electric field strength or electric field intensity. What is that electric field strength and electric field intensity here? So electric field intensity or electric field strength is nothing but a force experiencing by a unit positive test charge. So what is that electric field strength here? Force experienced by unit positive test charge. So look at here. What is that electric field strength here? So electric field strength is defined as it is nothing but a force experienced by unit positive test charge here. So force experienced by unit positive test charge here. If you remove the proportionality sign, I will get that proportionality constant. So that is proportionality constant is E here. So this E indicates that electric field strength. So what's that E here? Electric field strength or electric field intensity here. So shall I write that electric field intensity E is equivalent to a F by Q here? What is that electric field strength here? It is the ratio of force experiencing by, or it is the force experienced by unit positive test charge. So E is equal to F by Q naught. Here that electric field strength is a vector physical quantity. Vector physical quantity. So electric field is a vector physical quantity. What is the SI unit for this electric field strength? Force is in terms of Newton. What is the SI unit of charge? Coulomb. So Newton per coulomb. What is the SI unit for that electric field strength here? Newton per coulomb. And another one more unit is there. In next chapter you may consider that relation between field and potential. So from that relation we are getting one more SI unit, that is volt per meter. So what are the SI unit for that electric field strength here? Newton per coulomb or volt per meter. So what is the dimensional formula here? Dimensional formula. So E is equal to F, force. What is the dimensional formula for force? M1 L1 T to the power of -2. So what is the dimensional formula for that charge here? So I is equal to Q by T. So Q is equal to I into T. So I means current, ampere into time here. So M1 L1 T to the power of minus 3 A to the power of minus 1. What is the dimensional formula for electric field strength here? Dimensional formula for that electric field strength is M1 L1 T to the power of minus 3 and A to the power of minus 1 here. So in order to understand that electric field strength, so I will consider that electric field strength due to a point charge here, or electric field strength due to a source charge. So I will consider that equation for electric field strength due to point charge or source charge. So I will consider that equation for electric field strength due to a point charge or source charge. For example, here I will take that one point here, that is point O. On that point O, I will consider one source charge here. What is that source charge I said here? So a charge which can produce the electric field. So that charge I will name it as the source charge. At a certain distance from the source charge, at one point I will place one test charge here. What is that test charge? A charge which can test the effect of source charge. I said distance between this source charge and the test charge is R here. What is the distance between source charge and test charge here? Distance between the source charge and test charge is R here. So now let me write that force experienced by source charge on test charge is Q naught. So between these two charges, what is the force? So from the Coulomb's law, F is equal to 1 by 4 pi epsilon naught Q into Q naught by R square. So let me write that what is the electric field strength value. So I know the relation between field and force. What is the relation between field and force? E is equal to F by Q. So let me write. So we know that relation between field and force, E is equal to F by Q or F by Q naught. So I will substitute that F value in equation 2 here. So I will substitute, put equation 1 value in equation 2. So what will you get it here? So look at here. So E is equal to, F means 1 by 4 pi epsilon naught Q into Q naught by R square whole divided by Q naught here. So test charge will getting cancel out here. So E is equal to 1 by 4 pi epsilon naught Q by R square. What is the equation for electric field strength due to a point charge here? What is the equation I got it here? Electric field strength due to a point charge, E is equal to 1 by 4 pi epsilon naught Q by R square here, where Q indicates what? Test charge or source charge? Q indicates that source charge here, source charge, and R indicates the distance between source charge and test charge. R indicates that distance here. So what's the physical meaning I get it here from this equation? E is equal to 1 by 4 pi epsilon naught Q by R square. It indicates that electric field strength depends only on the source charge. It is independent on the magnitude of the test charge. So look at here. So from this equation we may come to know that electric field strength value depends only on the magnitude of the source charge, and it is independent on the magnitude of the test charge here. So from the electric field strength due to a point charge, I got the equation E is equal to 1 by 4 pi epsilon naught Q by R square, where Q is nothing but a source charge, R is nothing but a distance. So electric field strength is independent on the test charge we will consider. So hope you understand here. So we'll move further. So in case of that electric field, I said, so electric field is nothing but it is the region around a point charge within which influence can be experienced, I said. Okay, so these electric field lines are imaginary lines. So whatever the electric field I will consider, so around the point charge field must be present. So these field I will represent by the lines here. So that lines is imaginary lines. Now we'll look at that what is electric field lines. Electric field lines. Electric field lines. What is that electric field lines, or what are that electric field lines here? So electric field lines are the imaginary lines which gives that non-mathematical visualization of the electric field. So look at here. So electric field means I said that E is equal to F by Q. I given that mathematical approach. Without mathematical approach, how shall I understand that electric field here? So electric field lines. So electric field lines are the imaginary lines. So whatever the field lines I will consider, those are all imaginary lines. So for my consideration, I will take certain kind of assumption here. So electric field lines outward for positive charge. So look at here. Electric field lines are outward direction for positive charge. For example, if it is a positive charge, what is the direction of electric field lines here? Electric field lines are outward for the positive charge. So look at here, electric field lines are radially outward direction for the positive charge here. And what about for the negative charge here? For example, here if I consider that negative charge, so electric field lines for the negative charge is inward direction. So look at here. So electric field lines for the negative charge is inward direction, and for the positive charge it is outward direction. So electric field lines outward for the positive charge and inward for negative charge here. So for example, what is the direction of electric field lines for two similar charges? For example, electric field lines for two similar charges. In theory examination, most of the time they ask the question like that. So sketch electric field lines for two similar charges and sketch the electric field lines for two dissimilar charges. Sketch the electric field lines for positive charge and for the negative charge. So what is the direction of electric field lines for two similar charges here? For example, similar charges means positive or negative. So two similar charges, like charges will repel each other. Then what should be the, or what should be the direction of electric field lines here? For example, if it is a positive charge means these are all the direction of electric field lines for similar charges, I said. So this is the direction of electric field lines for the similar charges. So for the similar charges, I will consider one is positive here, another one is also positive. So between that positive and positive, so how the electric field lines are oriented here? So for that positive and positive, so electric field lines outward for the positive charge, I said. So this is the direction of electric field lines for two similar charges. And what will be that? Electric field lines for two dissimilar charges. So dissimilar charges means one is positive, another one is negative, I will consider. So next one is electric field lines for dissimilar charges. Electric field line for dissimilar charges. So what is that electric field lines for dissimilar charges? So dissimilar charges means one is positive, another one will be negative here. So electric field lines, for the positive I said outward, and for the negative I said inward direction. So for example, electric field line for that two dissimilar charges, this is the direction. So you have to represent the direction. If you are not representing direction means you may not get any kind of marks. So electric field lines for dissimilar charges, also I can call it as a dipole. So drawn electric field lines for dipole. If they ask the question like so, sketch electric field lines for dipole. So dipole means it consists of one positive and one negative charge. So in next class I will explain about dipole concept. So just you have to remember that word. Dipole means it consists of one positive, another one is negative charge here. So electric field lines for the dipole here. So in case of that, so these are all the direction of electric field lines. So this is the direction of electric field lines for a dissimilar charges or dipole. So look at here. So basically I will understand what is that electric field lines here. Electric field lines are a imaginary lines, so which gives that non-mathematical visualization of the electric field. For the positive charge, field lines are outward, and for the negative charge, field lines are inward direction. So electric field lines for the similar charges. So this is the imagination, or this is the imaginary lines for that electric field lines for similar charges, and this is for dissimilar charges here. So electric field lines for positive, negative, for similar and for dissimilar charges. Now we'll consider what are the properties of these electric field lines. So let me understand that. Hope you understood these points. So positive charge outward, and for the negative charge inward direction. So this is the electric field lines for the similar charges, and this will be the electric field lines for the dissimilar charges or dipole. Now we'll look at that. What are the characteristics, properties of electric field lines? So now we'll look at that properties of electric field lines. What are the electric field lines properties? Properties of electric field lines. So we'll look at that properties of electric field lines. For the theory examination, most of the time for 3 marks they are asking the question like so. Write the properties of electric field lines. So first I will consider that. So what are the properties of electric field lines? So that first property is electric field lines are starts from the positive and ends with the negative. So remember that point. Electric field lines start from positive and ends with negative. So what is that first property? Electric field lines are starts from positive and ends with negative here. Electric field lines are starts from the positive charge and ends with the negative charge. So next property, I want to understand the direction of the electric field lines. How to understand the direction of electric field lines? In order to understand the direction of electric field lines, I will draw a tangent at any point of the electric field. For example, electric field. So this is the electric field. So I want to get the direction of electric field at point P, for example, or direction of electric field at point Q. So how to determine the direction of electric field here? So in order to determine the direction of electric field, I would like to draw tangent at any point of the electric field. For example, at point P, if I draw the tangent line, so this tangent line represents the direction of electric field. For example, at point Q, if you draw the direction, so if you draw the line, so that line represents the direction of electric field. So let me consider that second property, tangent drawn at any point to the field line. So electric field lines may be straight or curve, whatever. Tangent drawn at any point to the field line gives direction of electric field here, direction of electric field. So look at here, what is the second property? In order to understand the direction of electric field, what suppose I have to do? I will draw so straight line, or I will draw tangent line at any point to the field line. So that tangent line represents the direction of the electric field. So next property, so electric field lines never intersect each other. So that is important here. Electric field lines never intersect each other. So why electric field lines are never intersect? So for example, I drawn that, so this is positive charge and this one will be a negative charge. So I am drawing that, so electric field like this, in this fashion. Okay. So here that electric field lines are not crossing here, electric field lines are not crossing here. Why electric field lines are never intersect here? Why? Because for example, if suppose electric field lines are intersect here, so at the point of intersection, so it may possibility of that two tangent line here. So that is not possible. Why? Because electric field line having a unique direction or single direction. If that electric field lines are getting intersect, means at the point of intersection I will get that two tangent line. So if I get the two tangent line, means it means that what? So there are having two electric field line direction. So but that is not true. Why? Because electric field line is a single direction. So that is from positive to negative. If suppose if that electric field lines are getting intersect, means it means that at the point of intersection you may get that two tangent lines. So two tangent line means two directions. So it is not possible. So electric field lines never intersect each other. So next one is electric field lines never form a closed loop. Never form a closed loop here. So electric field lines never form a closed loop. What it means here? What's the mean of closed loop here? For example, closed loop means, for example, if it is a positive charge, so it will end to the same point. So this is a closed loop. Is it possible to get the closed loop here? For example, for positive charge I said electric field lines are outward. So in order to get the closed loop, it should be inward to the same positive charge. Is there electric field lines are inward for the positive charge? No. Electric field lines are always outward. So this field line will be outward. It is not possible of getting closed loop here. So that is what I said, that electric field lines never form a closed loop. For example, this is negative charge. For the negative charge, electric field lines are only inward direction. There is no outward directional electric field. So electric field never form a closed loop here. What is that fourth point here? Electric field never form a closed loop here. And last one is electric field lines takes continuous curve. It may not break at the middle like this. So it may not having a break here. Electric field lines are formed, or electric field lines are continuous curve, it doesn't take any kind of break here. So field lines are continuous and it does not break at the middle. So look at here. So electric field lines. So electric field line is nothing but it is a imaginary line which gives that non-mathematical visualization of the electric field. So for that purpose, for the positive charge, field lines are outward. For the negative charge, electric field lines are inward direction. And properties of electric field lines. So electric field lines starts from the positive, ends with the negative charge. So in order to get the direction of electric field, what suppose I have to do? I will draw tangent at any point of the field line. So tangent drawn at any point of the field line will give the direction of electric field. So electric field never intersect, I said. Why? Because at the point of intersection there is two directions, so it is not true. So electric field lines never form a closed loop. Why? Because for that positive charge only possibility is outward electric field line, for the negative charge only inward electric field line. So it is not possible of making that complete loop here. So that is what I said, electric field lines never form a closed loop here. Electric field lines are continuous, it may not break at the middle. So these are all the properties of electric field lines for theory examination. So most of the time they will ask the question like so, write the properties of electric field lines for 3 marks. If they ask for 1 mark means why electric field lines never intersect, why electric field lines never form a closed loop, like that. Such kind of questions they may ask in a theory examination. So hope you understand till now. So in next class we'll continue about a remaining thing. So thank you.